Hello everyone and welcome here on the second deep walkthrough tutorial. My name is Paul and today I will provide a complete overview of the Gene software interface with its all objects and functions, learning you what they are for, how to use them and control them. This tutorial will be longer and more detailed, but I will not start from the beginning, downloading, extracting the files and making the software activation. So, if your Gene is not downloaded and activated yet, please watch the first quick start tutorial and come back later. Some functions are more complex, and even we dive deeper today, they require extra tutorials. But at least I will show you how to work with them, knowing what they are for, to be able to handle them and run them from now. This even will be probably the longest one I will ever do, so I will not hurry today, rather saying something twice than to forget it. So please take your time, be relaxed, and we are ready to launch right now. Last time we created the folder Gene 2.0 on our disk or on the screen, the desktop. I will open it, and we had prepared the activated original and also the copy my lottery number 1, which we used for the quick start. Today we take the activated original again and we create copy, and I will name it my lottery number 2, which we use for today's tutorial. So here it is, my lottery number 2, and I will open it and insert the Excel password. And enlarge it to whole screen. We have the Gene interface, and actually the tutorial will be always in the most cases from the left to the right, and we start with the primary settings, clicking the activation button. Then we select the language. We have 8 languages available here, so if we select for example French, then all the names and menus will change to its language. Also the printed interface will be in this language as well. We can stay today with English, and you can also add your own language. It's simple, and for this reason there will be created special tutorial. After language, we can select the skin we like to have. We have dark skins and light skins. One of them dark, let's say take the black one, which is good for your eyes. I like and my favorite is the Matrix, as it looks like from the famous movie. Also you can select the one of the light ones, like the yellow one, and today I will stay with the blue one, but marked by X to distinguish the start and end button for today's demonstration. Then the most important thing is to select the lottery we like to play. It's usually our favorite lottery. There are more than 40 presets here, and over the lotteries from all the world, and we can also add the lottery, downloading that from the internet, from the Wave Hunters group, or you can create your preset by yourself, and for this there will be also special tutorials. So today, or in fact we have here actually 3 types of lotteries. The first one is usually with only one draw, like Fantasy 5. So we have here one draw, and we checked on ticket 5 numbers, and 5 numbers are drawn from the 36 ball at drawing machine. The second draw is here, and it's empty as we have only one draw. then the count of the same draw in this case is 0. There is only one draw. And finally we have the game index. This is the number of the lottery, as we have number 4 and we are starting with number 1 here, and this is number 0, my game, which we can create our preset at first, because if I select my game, then it's empty and it has just the index 0. So Powerball has index 1 and so on, 1, 2, 3, 4. So that is the lottery with one draw. Then there is a lottery using one draw but have a little bit different options. So we have one draw and we are checking on the ticket 6 numbers, but 7 numbers are drawn from 40 balls in the drawing machine. Here we have also 0, the same draws, and game index is 5. And finally, most of lotteries are using 2 draws. These are the famous lotteries played over the world, like a Powerball, which we select for today demonstration. And you can see it has 2 draws. 5 we select on the ticket, and 5 numbers are drawn from 69 balls. And the second draw has 1 number we select on ticket, and 1 number is drawn from 26 balls. There are no same draws, they are completely independent. The first and the second are independent. The index in our case is number 1. To have the same draws, there are a few lotteries. They are very rare. One of them is from Slovakia and the second is from Czech Republic, but I have never seen other lotteries all over the world. So most of the lotteries has 2 draws and both are independent. Then we need to select a mode for each draw. For the draw 1 it can be mode A or B, and for draw 2 it can be also A or B. So we can have it A and A, or B and B, or A and B, or B and A. What I recommend is to keep the same mode for both draws. So we have A or B and B. Now I'd like to explain what the mode means, as you understand it, what you are selecting. For that reason I will open the user guide we had downloaded and extracted on the Quick Start tutorial, and on the left there is a navigation panel where we go directly to the functions, and here we found the modes. You see there is the menu, and for the modes I plan to create also extra tutorial, but I will try to explain it more briefly today. So the mode B means that we have in the pool still the same amount of numbers. For example, in the range from 1 to 6, so we have 6 numbers, and if we select one number, there are still 6 numbers. So if number 3 is drawn, it's still inside. And what can happen is that during the second loop, to generate randomly second number, we can randomly select number 3 again, but it does not correspond to the real lottery, and the gene is able to recognize it, and it will exclude the number away, and it will make a rewind and draw the second number again. And in case it's different, which we have here number 5, then the machine is, or the generator is generating a third number in the fourth loop. The count of rewinds is stored and printed in the output box, and if the count of rewinds is equal to 0, then the quality is very high and we don't need to care so much about this. But if it's higher, then we might look on that and say, yeah, we have good results, but there were a lot of rewinds, so it's not fully according to the real situation. So that's the mode B. It's quicker, the algorithm is simpler, and you can use it. And I had programmed it on the beginning, but then I extended the gene with the mode A, which is now here as a first one, and it corresponds fully to the real lottery. So we have in the beginning 6 balls inside if we have the range from 1 to 6, and then we select one number, number 3 for example. And in the second case we are not able to select the same number at all, so number of rewinds will be always 0. So here is not the problem like with the mode B. So then the second number is selected, the amount of number is reduced to 4, 2 numbers are outside, and finally in the third loop we are selecting randomly third number, and 3 numbers are still in the pool. So that's all about the modes, and I will hide it for now and come back again to the interface. And for today I like to keep the A mode for draw 1 and B mode for draw for the second draw. Even it's recommended to keep the same modes for both draws, and actually I prefer you to use the A mode as it's more close to the real lottery. But you can test also the B mode and maybe you might be surprised with nice results. So we are ready with the mode, and now we need to set up the pulse length. It's an additional function, will be explained during the generation, and for today we put 20. It determines how the amplitude in pulse will be long, and it's then represented in the pulse graph here. Then we need to set up how big field we want to have for the record function, and the field determines that it's the size of how many generated sequences we want to store during the whole generation, and we can store maximum up to more than 2 billion values, so which is about storage about the whole running gene for 2 or 3 days. Today I make it a little bit smaller, so I put there 10 X rows and 500 Y rows. These X is just, it should be multiplied by 6. It means that we have 60 rows and 500 columns, or I would say rows as well. So these are the size of the metrics, and there are limits which are mentioned in the user guide. Let me show it as well to see the limits, and please take these values carefully, because let's I go to the monitor section and take them easily, because it can very slow down your computer, and the generation can be really slow, so you might do more tests with that. And we go here in the monitor to the record section, and here you see the limits. For the X row you can have minimum 1 and maximum 2700 or 42. Some Excel doesn't allow then more 42, as it does not allow more than 255 lines, and as I mentioned, it's multiplied by 6, so then we can have only 42 as an X coordinate, and for Y it's more, it's more than 1 million and at least 1. So as I mentioned, we can have actually more than 2 billion recorded cycles. So it's about the record field. The pulse and record then is represented here, and during the generation I will show you how to work with them and what they are for. Then we need to set up where the printed interface will be placed. These are the coordinates of the starting point. So we put a row, the minimum can be 25, but I am used to use 27, and the column we put number 2, which is exactly this point. You might have some reason to print it from here, that you like to make some notes here, or from here or here. It's all up to you. Only the limit is basically you cannot put here 0, and you cannot put here smaller values which can go below this interface, like 25 or less. So in fact, I prefer to keep this value all the time. Then very important parameter is the count of the previous slots, and it's actually the history of the lottery, as I explained in the principle of the gene based on the wave-like theory. So the history, the minimum can be 1, but it doesn't make sense to put just one previous draw, and then the minimum, we should have at least some sample of the history, and at least put here 3, and you can put there 10 or 100 or 1000. There is no limit, and actually you can also test the whole lottery from its beginning, it was started, to these days, and this history can be copied from the internet, that you will download the complete file, and by some copy and transform procedures you can place it without handwriting inside. And how to do it, I will also arrange a special tutorial, but today we stay with 3 to arrange the setup quickly. Then count of future lots, we put today 2. It can be also 0, and even we put 0, we will have always generated numbers for the next upcoming future day, which is marked by F. You will see that later. But then there are, you can draw and continue to the future, to the second and third upcoming day, and these columns are called P1, P2, and to Pn, and the P means like predictions. Yeah. So we stay to show it with number 2. Then seed 1, it determines how the chain of random numbers for the draw 1 generator will look like, and it can be whatever number you wish to place. The same is valid for seed 2. We can put whatever number, it just take care that it's different from seed 1, so these two numbers are different from each other. The last seed 1 and 2 we keep empty. It's used for the transfer operation, where we want to save our generation at some certain point, and we want to start it from this last saved point, and these last saved seeds will allow you to do it. So it's filled in then by this operation automatically, and you don't need to care about them at all right now. Then we have the recuperation. It's really important thing here. And I will explain also during the generation. And in fact, just in a simple way, it means we, for example, generate numbers for first day, second day, third day, but we do not have, for example, many matches with the third day, and we can move the generated numbers and compare them from the third day with the second day and with the first day. It means that we can check as much combinations as possible to get a much better result than without doing this recuperation. So the chain of random numbers, we will check all these possible combinations that can happen during all the generation. So it is speeding up the generation, is enabling you to getting better result, and that's why it's designed here and programmed. And the maximum value for recuperation is equal to sum of previous and future lots. So in our case it's number 5, 3 plus 2. If we have the history 10, then we put 10 plus 2 is 12. So we put here number 5. Then number of results, it's a value how many last best results and outputs we want to keep printed. In our case we put today 6, and I will little bit provide more information about the number of results. So let me open again the Gene User Guide, and we go to the chapter named Parameters, and there is a number of results. So if I scroll a little bit down, just jumping, and we have several situations that can happen using different settings, so we can have different number of results we see on the screen, and sometimes it might confuse you. So that's why I came to here to show you what can happen, and you understand what you are getting actually. So it's related also to this display button, which I can disable or enable. And so if we put number of results 0, which we can, and the display is off, then no boxes are printed. If we just check on the display and 0, then only one box is printed, but this box doesn't show you the best result. It's only the online monitoring where it's always this box is overwritten as the generation is running. So it shows you the complete generation, and you see it online what is going on the background of your computer. This option, so we have, usually it's good to have it, and it can be disabled so the monitoring is just on the background but not visible. And it's why to do it is because we like to keep the generation quick, but I will show that later. So that's the second case. We put 0 display, then we have one monitor box. Then we can put number 1, but the display is disabled. Then we will get 2 boxes, and it means we get the last best result, and there is the first box with exclamation sign. It's representing the best result we got until now. So this is the last best result, and this is the best result we got. If we have just one, then these two boxes will be always equal. So if there will be the last best, then there is also the last best. So it doesn't make such sense, but you can have it as well. And finally, or not finally, but if we have number 1 and we check the display, then we are getting 3 boxes. The first one is the monitoring one, the second is the best, and the last is the last best result. And finally, if we there is another case, if there are more outputs and display is off, then we have 3 last results and the best one, and one of them will be equal to the best ones. For example, we have result number 1, number 2, and best is number 3, so that number 3 will be here. Or we can have number 3, then we can have number 4 as the first is overwritten, and number 5, then the best will be here number 5. So it's like doubled, and you will see it, everything is marked and clear, and no problem about that. The situation we will have today is, as we put number 6 here, the display is checked, then we will get 8 boxes. With number 3 you have 3 boxes plus the top one and the monitor one, so you have 5. And in our case we will have 8, the 6 plus the top and plus the monitoring. So I think it's clear now. we keep 6, and I will show that on the printed interface that it's correct what I said. Then we place the swap 1, it's related to draw 1, and it keeps you assure you that the generation will be always unique all the time, so the sequence will never repeat. And the same we do for swap 2, and these two numbers should be different from each other, and also the bunch of these numbers should be different from these two ones. And these two last ones we keep empty as they are filled automatically. As I mentioned, is the same with the seed 1 last and seed 2 last, as they are used for the transfer and operations when we want to start from the last saved point. So these we keep empty right here. So we created we have the lottery parameters. These are always filled automatically, and please never touch them here, as you can cause some error and incorrect calculations. So it's only just to see how the preset looks like, and you don't need to touch it. You need always to make the preset in the game sheet, where which I will explain in the special tutorial. So we keep the Powerball here, it's filled. Then we filled the pulse record and all the needed parameters. That's actually all we need to do, and the filling is quick, but today I provided really a lot of information to understand what you are doing. Then what we need only to do is to set up what we want to see on the output boxes, and for this are these column of check boxes, and I will explain it. So on the output boxes you will always see the generated numbers. Its mark is there for the first and second draw. So even I will uncheck it or whatever, you will always see it. So there is not the option right here. The hit, its number of matches you will get with the history, it will be always printed. The hit in percentage will be always printed, and the rewinds will be also always printed, even it's disabled. So but this section I will explain later. So then we can select to see on our output box the number of cycles, the time when it was printed, the date when it was printed, how long time it takes to be printed this result, what seed 1 was used for the generation seed 2 was used, what is the quality of the seed 1 and the quality of the seed 2, and finally the proof function. The proof function and the quality of the seed are analytic tools that actually are not necessary to use, but if you want to dive deeper into whole generation and to analyze it with everything, and to be able to better decide what result to use or how the result looks like, then it's good to use all these tools and to use all these optional parameters. They will not influence your result. Even you will not select it, you will get the same result. It's just about to see more things on the sheet and to be able to decide and analyze it. Also, other thing, if you enable these, it's related. If you have more settings activated, then it might little slow your gene, but these ones are not slowing that almost at all, because they are saved on background, and here you are saying just deciding if we want to see them and print them. So I put them all on, and actually we are ready with the primary settings, and then we continue to make the secondary settings, where we need to click the setting button. And in this moment they are printed, all the boxes. Before the print, all the parameters were checked, and when they are marked by green, it means all is correct right now. If not, they will be marked by red, and you need to change the values if necessary. So we made them correct, and that's it. If they will not be correct, it will not allow you to print the boxes, and you need to change it and click the setting again. So now the interface with the boxes is printed. It takes a little while, so it was quite quick right now. And the hit, red, pulse graphs were updated with the right values according to the given parameters. Also, other functions were updated and adjusted. Now what happened is that the language, the skin, the game, the modes are frozen. It means we are not able to change them at this moment. Also, the optional parameters are frozen as well. We cannot change them right now. We just need to fill in the input actually and run the gene. That's all what we can do. And why we cannot change them? Because the output box already have the needed parameters we decided to use, and it should be frozen because now everything is prepared for the launch of the generation. And at this moment it's time to start to fill the input and the filter box. So we have the filter, and I will focus on it right here. We have here the hit graph, and the hit graph, they are represented the best result and also the filter setting. And the filter setting is about how good results we want to pass through the generation, and we want to analyze them. And so if we put a number 3 for the first drawing day, then we have to get 3 matches. So we generate 6 numbers, and 3 of them should match with the history of the first day. If not, if we have only 2 matches, then the generator stops here and it generates again numbers for the first day, and it will not generate numbers for the second day until we go over the filter setting. So if we have 3 matches, then it continues to the second day and it generates numbers for the second days. There are no limits at this moment, so if we have 0 matches, it will continue and generates numbers for the third day, where it will continue to generate numbers for the upcoming future day, and then for the predictions days which correspond to the future loss is number 2. So that's the filter setting. We can put it like here, that we put number 2, and the maximum number can be number 6, and the number 6 is, we can have in maximum 6. Sorry, I take it I take a drink. So we can have at least, or in maximum, 6 matches. So we can put to the filter number 6, 6 and 6, and now the filter is very tough. It means that it will print only result which will have 6 matches for all these history, for all 3 days. it's very tough, and I do not recommend this, because it might happen that during several days you will not get any result. It will be still empty, because it's really hard to get in a shorter time such results, having 6 matches for every day. So the filter setting, you can play with this, and please keep here keep here lower values or some reasonable values. And for today, to see something, I put here 0 or leave it empty, it doesn't matter. And the last one, if I want to increase the end of the wave to have it at least 1 or something, so I put here number 1, and it's my filter setting for today, just to see more. But when I have more time to run the gene, I put it harder, like I can put here 2 and 3, and my results which I get will be always higher than 2 and 3, or at least equal to 2 and 3. So we will have waves like this that are increasing, and we can assume, according to the wave-like theory, that the wave can continue and in the increasing trend and then falling down later. So let me put it to this scenario 001. Then we have the input box, and we have here the history, as we put there the count of previous slots. So the history, we are keeping 3 previous drawings, and here we have for draw 1, where we are drawing 5 numbers or selecting 5 numbers and 1 number from 26. So actually there are drawn 6 numbers, draw 1 and draw 2, like corresponding to the lottery presets, so 5 and 1. And now we need to fill the input with the history of the lottery. So we go to the official website of the lottery, which is in our case powerball.com. I will refresh the screen, and we look for as the history now is free, so we look for the last 3 drawings and we put them into the input box. I will move it and write it here. So we start from with the oldest one, which we put to the first day, and the first draw has numbers, draw numbers 4, 6, 14, 20, 32, and the second draw is 13. Then we have the second day is February 27, it's 21, 31, 42, 49, 59, and the second draw is 23. Then we have the newest drawing from the 2nd of March, and it's number 1, 19, 25, 27, 68, and second draw is 21. So we are ready with the input box, and the C is related. The C we do not fill at all. It's related to the compare function, which is available after the end of generation, and I will explain that later. So we have filled in the history. We know what the C is, that we don't need to fill it before starting the generation. And something more about the lottery, I will enlarge it. And so we put just there here last 3 drawings, but if we want to have bigger lottery, just go to past drawings. On every lottery it can be on different place, but we have it here, and we can, for example, set up the history from January, from the beginning of this year, until today, and we click the search, and you can see we have such history that we can place then into the output box, for example with 20 previous draws. All is up to you, and all depends about your decision. So this I can hide for now. And before I start the generation and finish the secondary settings, I will just show what we have here. We have the proof box, which is only printed when this proof function is enabled, and so we decided to do so. So we see it here. If it will be disabled, this box will not be here at all. This is analyzing tool, and you just see here the values, and you don't need to put anything here. It's just to see and to take some observations of your generation. Then, as I mentioned before, we switch on the display. Now it's frozen, so you cannot disable it right now. So it's enabled and it's frozen. So as we decided to use that, then we have the monitoring box right here. It's marked by M. Then we have below this is the box showing always the best result, and the best result will be marked by exclamation sign. You will see that later. And then, as we decided, we have here the 6 boxes showing the last best results. So it's 1, 2, 3, 4, 5 and 6, and then that's all we have on the printed interface. So we have the interface, we finished the secondary settings, and we are ready to launch the generation. Before I do it, I switched on the monitor, and this monitoring is and activate the pulse and record function as well. So the monitoring is actually are giving values of the whole generation, how many cycles we ran, how long it took, and so on. So that's it, what we need to do. We can play with this during the generation, but I will set up before I start it. Also, what is not related to the monitor and it's independent, it's the autosave. And the autosave today, I put a lower value because it's after 1 billion cycles, it's just saved. It's good to use it not to lose your generation during time, so you won't be happy if you will lose it or something will fall down after 2 days. So you do not want to lose 48 hours of generation. So it's good to have autosave enabled, and I put here for today that I want to save it after at least after 500,000 cycles. So we put there 500,000. Let me, yeah. So every 500,000 cycles it will be saved, and the time and date of the save will be printed here. Because I'm playing today with the parameters a lot and doing a lot of stuff, it might happen that some error or some problem can cause and stop the generation. So then I'll be able to open it again today, not doing everything from the beginning, and start it from the last save point, and we can continue the explanation. So we have it, all is ready right now, and we start the generation clicking the start. Now it's running. We see we see that the record field is now created. The red snake is moving and it represents the monitor output box. And actually, if I will show it, you see how the values are changing. But let's say we will focus now on the left and right side to see what is going on, and then I will explain all the output boxes. So first I will provide these explanations, and in the meantime I will get some results that I can explain them during time. I will switch off pulse and record for now, and that's I will also want to explain them later. Maybe I can switch them on. Yeah, I can switch it off for now, just I can then explain that during time. So it's switched off to keep it running fast, and it's running now. And I'm starting with the monitor. So there is a master checkbox which is completely enabling or enabling the related monitoring parameters, and so we can control the counter, speed, average speed, time, pulse, and record. So let me show it. I will start with the counter. We can print the value of count every time. So if I put to 1, then every cycle is printed and this box is rewritten. And but in case the generator is running and it's counting the number of cycles which we see here, but we don't need to see it how it's running all the time. So it's good to move it to higher value, that the result is overwritten after every 100,000 cycles. And it's pretty good because usually the gene is really fast. You can also see following things. So if I put it to number 1 and I can switch it off, so it stopped. It's still counting but not refreshing the number here. I switch it on and now it's counting. I can do that. I switch off the master monitor and again it stopped and it's still counting. Now it continues to refresh. And the same is with all these things. So this one is master, then it's running. So I put that on, and then the second parameter is the speed. I can refresh it also after every 1000. Now the speed we have is the actual speed of the gene right now. And as we are playing with all these parameters, the speed is quite low. We have just about 2000 cycles per second. It's not so long, but we can reach 17,000 cycles per second. And this value is also in the speedometer graph, that you can see how it's changing. It is the red lever. The speed meter we can also hide not to see it, which will speed up the generation as well, and we can show it again. So that's what we can see. It's updated every time. So I put the value to the higher. I can also, when I stop it, I can also stop it and it's not moving anymore. Or I can stop it like that, yeah. It's the same case like with the counter. So I put that up, and then we have the average speed. It is the speed which we count from the beginning of the generation. It depends how many cycles we had until now and what the time already run. So we have this amount of cycles, and the time is it's running now for 5 minutes and 21 seconds. So that's the speed, and the speed is shown by the blue meter here in this graph. So these two speeds are shown here, and you can see how your gene is quick. Then here we have the time, and the time is represented in the first is days, then we have hours, minutes and seconds. Now it's running 6 minutes and 7 seconds. We can pause the gene and the time will stop as well. So now the time is not considered. Then we can continue and the time is running again. Also, if we save the gene and open it again, the time in between will not be considered in the generation. So it's counting only the time when the gene is really running. We can also watch the time more often. So when I put it, then you see it's showing every second change. So I move it up. That's the same thing. I can disable it. The time is still counted, so don't worry about this. I can disable it completely by the monitor. Then we have the autosave I already showed here, and it's saved after, at this moment, after every 500,000 cycles. We have first saved at this date, it's 3rd of March 2019 at 9 o'clock and 20 minutes in the morning. Yeah, so the autosave here. Also, if we save the generation by the save button, the last save will be printed here as well. But this autosave, if we uncheck it, it's not related. It's the autosave works independent to this master monitoring. Then we have here the pulse function, and I will enable it right now and to show it how it works. We have value here, it's number 4, and it's actually the count of previous draws is number 3 plus 1 future draw. It doesn't make sense to have bigger pulsation than this sum, and it's usable when your filter is set up. If in your filter is 000, it doesn't make sense to have the pulse function and to see the amplitude moving. And I will show it what it's for. Sorry, I took the different function. We have the pulse here, and I will put to 1, and it's showing as it's going. I can show it in the monitor box. It will be a little bit slower, but you can see it's generating number for the first day, for the second day, for the third day. But if the setting, for example, we have 0 matches here, is we have still 1, but if we have 0 matches here, yeah, it's not changing. So then you see the pulsation, it cannot get over the filter, and sometimes the pulsation can be only between first and second draw. Yeah, now we are getting, yeah, you see we got only to the third draw, but we did not get to the F draw. Sometimes we get, sometimes not, and it corresponds to the how often or when we pass the filter setting or not. Again, you see, and we are keeping the last 20 pulses here. So if we put number bigger than 20, for example 100, then it will be much more hills there than we see right here. As I mentioned, if the filter setting is not hard enough, then it doesn't make sense to use the pulse. So we can just switch it off, and it's not moving there, it's not slowing down the generation, and you don't need to care about it. But if your filter setting is hard, then it's interesting to see how far the gene is getting. Yeah, it will not so slow you, but you will see how far it's getting, and that's the purpose of the pulse function. And as I mentioned, I will run it again. So we are going from the first draw, second draw, third draw, and last one, fourth draw. And as it's here, we are showing the pulsation from the first draw. But maybe we want to see the pulsation not from the first draw, but that we want to see pulses when the gene gets more to the future over the second draw. Or so we can put number 2, and you see how it changed. It's just pulsing from only in case it went to the second draw. Yeah, so if the setting will be here on the filter, for example number 2 here, then it will not show you that it did not pass the first draw. So it will not move until it will go over the first draw and goes into the second draw. And I can put here the 3, and it only shows if it gets 3 and then over, and the maximum is 4, and then you will see nothing. It's only in case I got over the fourth one. So this value is adjusted according to the number of last draws and the future one, and the same value is here. So all is related in the different settings. These two values, this one will change automatically according to the count of previous draw plus 1. So I think I was able to say everything about the pulse function. I will switch it off, and then we focus on the record. I just disable it just to show you how it looks like. So we have on one side we have a number of draw days. It's from 0, in this case it's to 6. Just take some water, some drink. Yeah, before I start with the record, the pulse can be hidden as well. So it's now off. Now the record will be hidden and shown as well. If you hide everything like this, then you can also speed up your generation as well. So I can recommend it when you run it and you don't need to watch it, then it's good to hide it, because then you can show it every time you like. And now let's look at what we see here. So we have on the vertical line the number of cycles from the beginning until now. Actually we stopped it, so it's not until now, but until it was stopped, the record. Then what we have here is the primary or secondary axis is showing the number of drawing of the draws, let's say, and the number corresponds to the history, which we have 3, and plus the future lots and plus the predictions. So in our case it will be always equal to assume the previous lots plus the future lots and plus 1. So in our case it's 3 plus 2 is 5 plus 1 is 6. If the history will be longer and the prediction longer, then this value will be higher as well. Then and it's related to the blue line, which is almost equal to pulsation we've seen in the pulse function. I will explain later because I will now focus on the result line. And what we are recording here are the all or the best results. And let's show it. We can have the best result, or the maximum we can reach is 100%. It will happen only when we have matches of the history with the generated numbers for the same days, the first, second and the third day. And you see what we are getting, which values we are getting here, and we see that we are quite low. And we also see that there are some signs. So the red amplitude and curve are representing all the not printed, but all the results. And you can see how big matches we got in percentage. And then there are peaks which are marked by a green triangle, and these are the printed best result. I will try to enlarge it. Then there are triangles marked by red, and you will see them later. And these means the printed results, not the best one, but all the printed results. And then there are the black square, which means the start of recording, which is enabled. So I will try to make it a little bit bigger. And you see in the beginning we got the best result, and then we started to have result with the percentage around 10 or 20%. And there is the pulsation. And let me show you, I will open something in the in the user guide again, and I go to record function, which will be under, it should be under the parameters, or not parameters, sorry, under the monitor. We go to record, and what I want to show is, so that's the description which I like to show. So this represents the pulse amplitude. It's very similar to pulse I showed before, but it will be a little bit different. Then this is the curve of all results that went through the filter. Then there are the printed results by the red rectangle, and the top results are the green rectangle, and the square is always the start of the recording. We can see it right here. So we have the best results. In the between we have some printed results, and there are all the results went through the filter. We can see also how high the results were, as we have on the beginning the best result, and then the best results will be more rare. So then we have here 3 options. The first one is showing all the results that passed the gene, and also it's showing the best and all printed results, and also the amplitude curve. If we select the option number 2, the pulse is not visible at all, it's not recorded, but we have all printed results, the best, and all results which came through the filter. and the third option that we are showing only the best result and the printed results. So each option, the first one is the speed consuming and the data consuming in the memory. The second option is less consuming, and it's actually its preferred one to see the trends and how the position is, and to see if there are some repeated patterns. And finally the last one is just to see the result and what is going on. So it's also good to look for the distances between the best results and many results. If you see some pattern, and from that you can be able to predict or distinguish if the results I will select as the last one has some chance to have a good win with the real lottery. This tool, I would repeat that it's the scientific tool. You don't need it to use it for your generation, but if you want to go deeper into the gene, what it knows, then it's from time to time it's good to use it and to watch what are the results. Actually, it's the first proposal of the record function, and I plan to, in the next releases, to update this record function to be able to store without the speed reduction to the separate file, and make extra automatical analysis, giving you some good values or recommendation for your generation. So I will start the record right now, and I will switch off this one to make it faster. And there are several things we can do. So we have I will stop it again for now. So we can enlarge some area. If I move the upper and lower scroll bar, then I will magnify it, so I am displaying only this area. So I can magnify it more, like that, to closing that. And I have some kind of magnification, and I see the waves here. What I can also do, I can link these two scroll bars, and I can then move it, and it's moving together, so I'm actually browsing the whole record. For example, I go to the end, or I can go to the beginning, yeah, to see. I can also make auto, which put automatically the indicator to the end, and it shows the complete record from the beginning to the end. It can always change because I am able to stop it and reset it, so it's then automatically adjusted. So I can do that again, and that's the first thing, how to manipulate with this. So we have the auto adjustment, then the linked function to magnify the generation. We can move it with this to see half of them, yeah. So it's all up to you, and this allows you to just search inside the recorded values. What I will show you, we have the second thing, and now we have the option 1, and we can change the amplitude, and here is the amplitude a little bit bigger. So if I put to 1, the minimum, it goes, you see that. I will stop it for now, and it goes from 1 to the maximum. I will magnify it just to see. And you can see one thing here, as we have the filter on the third day, so you see that some draws did not pass the third day at all. You can see it here, and just when it passed, then it printed also the numbers for the future, for the upcoming and other draw. So if you pass the filter, these three columns will be always generated. So you can see it here. So we have several tries did not pass the filter, so the results were not printed. Then one result was printed, then twice it was not possible pass, or once, then it was printed, then again there were several types, and you see that the filter is excluding many weak results here. I can run it again so that you can see. I can also change that, and you can see how I change the amplitude, that I'm interested only from the second passing, and you see that here. So from the first, now we are interested from the second. We can be interested from the third one, and you see it's showing only the things that passed the filter right here. So we are here, then we can get maximum here, it's the fourth one, and you see it right here. It doesn't make sense to make it to 5 like correspond here, or to 6, because when we pass the filter, it will always goes to the P1 and P2. So that's the limit here, and that's a little bit different from the pulse. The pulse function works only to show if it passed the filter or not, and the amplitude in the record is extended from here to the end, so it's showing everything from here. And that makes sense because we are recording the results, and the result is printed only if it goes to the end of the generation, which is at the end of the output box. So that I showed this function here, I'm changing that. Just sometimes that's why it's a little bit slower now. Then I can select the second option, and you see that the pulse amplitude will disappear, and we will have only results. Just it takes a little while, and as the field is smaller, we are recording only values in the size of this field. But if we fill the field completely, then the first values are again overwritten, so we keep only some amount of data. And you see we have only the snake. At this moment we don't see the best or the printed results, as there is no better result than we have until now. So this we've seen in the beginning, and then it from time to time it will change. But you see it's nice, like a pulsing of the heart or whatever, and from time to time you see that. And it's storing class values at this moment because it's not storing the amplitude, so only the values passed through the filter are printed here. So it's changing not so often as it was before. And finally, the third option, you will not see anything right now. It will not change because we do not have at this moment getting a better result than we got until now. So if I go back to the gene, we should wait to get these, and as the result to be printed, it takes a lot of time or more time, then it's just one data stored. So if you select the third option, it's not the memory or also speed consuming, and you can keep it just in the third option just to see how often and if there is some pattern between the results were printed. Like I see here, we have some sequences, then some empty spaces. We have some best results from the beginning, that after this period we have first and second best result. So all this is, and in our case I think the third option is something we can use. So that's almost all I wanted to show you on the record function. What I can do also is this. I can stop it, hide it, and let me show it here. I will try to stop it. And disable it. I will try to pause the gene. And what I wanted to also, the last thing to show, is that you can reset the generation right here. At this moment I'm not able to reset it, but I will see later how to reset this generation and the record function. Okay, so let me switch it off. We will keep it for now, and we explained all the things we have right here. Only the missing I did not explain is the gate, which is just here. I will not touch it at this moment, and this will explain after also the transfer function. So these two will be explained later, and I hope I will not forget it, explain it. Then the second thing, so we explained the record and so on. Now we can go to the output boxes we have here, and we can continue the explanation here. So if we look there, we have display, and this shows you, or what we activated is what we want to look on that online. And I will continue the generation, and here in this box we have all the online monitoring, and it can be switched off completely. So all these things are stopped, not moving, but the gene is running on the background and still working. So it's preferred to have it switched off. I switch it on, then I can switch off 3 sections. One is the draws, so I switch it here. That's the first section. You can see it's not moving anymore, and the rest is moving. Then I have the second info, which I can switch off. These are these 3 lines. They are not moving at this moment. Only the proof function, but it's somewhere else. It's here. Then I can switch off the third section, and is not moving at all. I will switch it on again, and here the draws are running, and they are stopped. Then the hit is stopped now, and now it's running. There you see, now it's running. If I stop the hit right here, then also the red snake will stop, because it represents the number of hits we have here. So I can stop the hits in the percentage is the other line here, and so on. So the rewinds and the other parameters, all I can stop here and so on. I will run it for now and will explain the output boxes. So all the output boxes are the same with the same things but with the different result. So we have the number of output box. It can be marked by M like the monitor. It can be marked by exclamation sign representing the best result, and then it's marked just by the number of the result. Yeah. So we have at this moment first, second, third result, and no more result printed. So new result number 4 will be printed when it will be better than result number 3, where we got 2, 4, 1 matches and we got 39% of matches in percentage. So that's the monitoring. Then we have the generated number for the draw 1 and draw 2 for the first day, for the second day, for the third day in our case. Then we are generating numbers for the upcoming following day marked by F like a future, and the gene, as we decided to have future lots, there are 2. Gene continues to generate numbers for the second upcoming day and for the third upcoming day. Then the numbers or the gene goes back and generating numbers again for the first, second, third, trying to get as much matches as possible with the history of the lottery we have in this input box. So we are generating numbers and then they are calculated the number of matches. You can see how it's changing as we have 1 match, 1, 1, and as the snake is moving right here, it corresponds to the matches here. Then we are showing the hit in percentage is the same value, but it's in percent. So if we have 1 hit, it's just 16% off from 6 numbers. If we have 2 hits, it's 32%. You can also see, and this I wanted to show, that sometimes it's not overwritten, sometimes it means that the gene goes in a chain to the end, but if there will be less than 1 match, the filter will stop it and it goes back from here to back to here to generate again. Depends on the filter settings. So sometimes it can stop here, and if it passes it will stop here and go back in a loop. Then we have here the proof function, the value which is printed with in the desired time, what is equal the proof value. The proof I will explain later together with the table. Then we have hits in percentage, as I mentioned, is equal to the hits, but it's recalculated to percentage. And then here we have the prediction. It's giving us the this is the average of all hits, is giving us the prediction. I would rather to show it in the best result. So we have here 2, 4 and 1 matches, which in percentage is 33, 66 and 16, and the average of them is the 39. So it means that 39% of these numbers shall be drawn in the real lottery, of these numbers which are dedicated to put on the ticket the upcoming lottery day. Then we have here the number of rewinds, and as I mentioned, it's related to the mode, which is A and B in our case. And for A there will be always 0 as there are no rewinds, but for the B, which is relevant to the second draw, there can be some rewinds. Maybe we can look if we have some rewinds and we see the quality of generation is good, as there is the number of rewinds is 0, and the number of rewinds is relevant to all generated days sequences. the matches are relevant only to the history, because these ones we cannot compare with anything. The future does not exist yet. So this is number of rewinds. We have it at this moment still 0, because it's very rare to generate the same number. If we are selecting only one number from 26, then it's very rare to generate the same number again. So that's why it's not a problem to use the mode B as well in your generations. Then we have a number of cycles, but these they are changing right now as the online monitoring is on. So I will explain that in the best result output box. And this result number 3 was printed after 51,000 cycles, and it was printed at 9 o'clock 60 minutes 35 seconds. In there can be there is in the date 2019 and the 3rd of March, and it was we got this result after 1 minute and 39 seconds of generation. So we could have here after longer time, we can have here is the days, and there is hours, minutes and seconds. Now it's running just as we look here, it's running 39 minutes and 0 days. Also the cycles, there is until the billion. When we reach the billion, then we have here the number 1 means 1 billion, and for example 51,000. Yeah, so it's still no billions were reached here. And the duration is also the days, as I mentioned, hours and so on. Then we have the final, is what we are looking for, are the how these numbers were generated, and there are the seeds for the first and second row, and with these seeds we were generated the sequence starting with number 4 and with number 1. We have here also the quality. Quality is equal to the function we had here, the quality for seed 1 for seed 2, and the quality is mentioned here, right here, that I will explain also later. Yeah, the proof and the quality I will explain later. So that's all to see the input box, and we can see have monitor, the best result, and then we have the last saved result. We got until now just 3 of them and waiting for the better 4th one. It's not happened yet. I can go up a little bit just to show there is the overall duration time, 33 minutes 48 seconds. About the results, we get the best result is number 3 with 39% of matches. So we have the best result here, it's with the exclamation mark, and this is the 39% of matches. And if we stop the generation and the drawing day is just and the hour is just in front of us, we select these numbers and we put them on the ticket, and we can assume that according to the wave-like theory we will have about 39% of matches, which is about 2 or 3 numbers, so we can have a lower price. Then we have the other printed results, where the best one, which is in our case number 3, is printed as the best one here. And if we get the 4th, 5th, 6th result, and then we get the 7th best result, then the 7th result will override the first result here, and this first will be excluded, and the 7th will be overwritten here and also the 7th result will be printed here. So it's going still in the loop and keeping the last 6 best results. And we see how the first best result has only 22%, the second had already 28%, and the last one has 39%. Yeah, I take a little drink again. Also, the best result, as we have here, where we have 2 for 1 matches, is shown in the hit graph, where we have 2, 4 and 1 match, and the green wave represents the best result here. So we just need to look for the green wave and then to select the numbers from the best output box. Also, when the lottery is over and we want to play the other upcoming day, then we should select these numbers to play. But this result is much stronger than this one, but you never know, maybe it can have the increasing tendency, so you can use them, but please consider that maybe the trend is decreasing, so maybe always it's better to produce new generation and to getting numbers and taking them from the F column. Yes, so that's what we have here, and now I'm going to explain the quality and the proof functions. Let's start with the quality. We have the Q1 and Q2. Q1 is for draw 1, and actually it says how our gene or generator of random numbers is similar to the generating numbers of the real lottery. So we have here the statistics of the real lottery, where every number from 1 to 69, how often it was drawn in the real lottery, and it's represented by this graph. And we can see that in the games sheet, where we have the statistics, where for example the Powerball, the number 1 was drawn twice, the number 2 10 times, 12 times, and so on. So this is represented by the dark blue curve here. Then we have the gene curve, and it's represented by the pink color. It's more even because the statistic here is quite low. And then the Q is calculated that we have the light blue or aqua blue, and it's the deviation between the real statistics and the gene statistics. That's the deviation. And then we calculate the all sum of the deviations, and it gave us number 30 right here. Again, also refresh the result right here. So we have number 30, and we have also number 30 for Q2. And you see here for Q2 there is a statistic of the 26 numbers. It's from 1 to 26, corresponding to second draw here. And we have the real statistics of the numbers. Then we have statistics of our gene, which is more even, and then there is a deviation. And the deviation, if we assume all these deviation values, we are getting also the number 30, which is quite interesting at this moment, that we have the same value for a different amount of numbers. But it's like this, and it's always updated during the time, and it updates rare and rare. And these parameters are show you how our gene is similar with the real statistics of the lottery. And it might help you, it's just scientific tool, but it might help you to also decide if I use this generation, or if I can predict that the the real matching will be really high or not. Then the Q we can see directly, as I mentioned here, as it's updated all the time, the Q is 30. But in the beginning, the Q was higher. It was for the third result, or for the first one, we have 115 deviation, and the Q2 was 123. The best result, it was already lower. It was 42 and 51. And actually, what is the better value is when it's lower and lower, it's better. We can assume then it's better for us. And we see that during the generation, it's more synchronized, the gene with the real lottery statistic. But it will drop down until some value, and then it will almost stay within the similar value. Maybe it will drop down a little bit, but not so much. Then we see on the screen right here. So these are these two graphs. We can hide them as the other graphs. We also, if I go back to the game sheet, and if you are making the preset, for example, there is a Mega Millions and there is no statistics at this moment, and the statistics are optional. And if you want to run fast and you want to make a quick preset without writing the statistics, which you can take from the official website of the lottery, then you don't need to fill it and it will work anyway. So the generation is not dependent on the statistics, and it's just the tool that might help you to with your decisions, but you don't need to use it as well. So I can hide it. What I can do, I can switch it off, so the calculation is not performed, and you can speed up your generation. And when it's off, you see there is off, and if the result was printed during it was off, then there will be off and off as well. So we can see in the monitoring directly it's off right here. I can switch it on whenever I like, and I can refresh the results by clicking on these buttons. It's just refreshing, because it's not refreshing all the time like we were refreshing. We are now refreshing this monitoring. It's not refreshed all the time. That's at this moment it's refreshed because it's on here, but I can switch it off like that. Yeah, that's better explanation. I can switch it off here, so it's not now refreshed all the time. And if I want to just to refresh it, just to see what is right, I can just click it right here or like here. Yeah, because now it's not off, but it's not refreshing all the time right here. I can keep it for now like it is. And that's all about the quality of the seed 1 and seed 2, how good the generation is basically. Then I will explain right now the proof function. It's quite more complex, but never mind. We have a lot of time today. As I say, take your time, be relaxed, and I'll be happy that I will finish this tutorial today and it will be available for you. But anyway, for some functions I'd like to make shorter tutorials just focusing on this function, and to provide a more detailed when you are interested, you get involved, and not to be overloaded with the informations like today. But in fact, you can also watch only a few sequences of this tutorial. I will also provide a timeline where you can just click what you are interested in, and that's it. But finally, I recommend to watch it from the beginning to the end, just to getting the overview in a smooth way, because then you will have the complete overview, understanding everything. Yeah? That's because I am providing that step by step. So the proof, now it's on, and you see it's changing during the time as the generation is running. And just I take a drink. So what we have here, we have the P like proof function box, and on the vertical line we have numbers from 0 to 6, and it corresponds how much matches we can have. We can have 0 matches where in the draw, or in maximum we can have 6 matches. So all is corresponding to the number of hits and so on, as we discussed before, also number of input numbers drawn. So maximum are 6 matches, we can have 0 matches. And then what we are doing, we are generating numbers for the first and second day, and we are getting some matches in percentage. And as we already know the numbers for the third day, we can compare the result of these 2 draws, or more, depends on the history, and we can compare this ratio, this result, with the real value of drawn or generated for the third day. And from between these two, I can show it in not moving. I will just stop it like that. So between these two, for example, we got average 1 and 1 number was drawn, or we have average here, it's 3 and 1 was drawn, so we got a negative deviation here. That's the proof is shown here, yeah? And so what we are doing here, it's a tool trying to see onto gene and trying to look how the theory works, if we are able to prove it or not. There can be several different approaches, and that's one of them I decided to create, to be able to see when we get enough matches on the first, second draw, if there is some trend increasing, decreasing, just to have it in front of our eyes what's going on. In a deeper, I would say, thinking, there can be different tools like I did. It can be designed, investigated, again as the quality. You don't need it for your generation, for your numbers. It's not needed at all, but it's just if you are more interested how good the quality of generation is, then it's good to understand to proof function and to little understand what it means for you. So we have here some kind of levels, and the gene can get with the previous draws, not the last one, it can get some sum of deviations, which is in the sum of deviations after the whole generation is, for example, we had if we had 0 matches in the first and second draw, it came to the level 0. Yeah, and in this we got in most cases the positive result in the third draw. That was in all cases we had the positive, so it's really and we do not have negative. It's logical, because if we have 0 matches we could not have minus matches. Then if there were matches equal to 1, we were in the first level, like we have here the 1 and 1, then we got more positive than negative things. You see that we have 874 positive but no negative, so it means there were 1 1 but not 0. And now it's quite clear and evident why there are no mines, because we set up the filter into number 1, and in this level then the result, if you see that, it's quite distort. The picture is not relevant to reality, because the negative values were excluded and the generator came to the beginning and it's not stored here. So that's other thing for the proof. If you want to use the proof well, there should be 0 in the last draw. You cannot use the filter setting here to have it correct. But anyway, it can work for levels higher. So if we have higher matches corresponding to number 2, like for example 2 and 2, the average is 2, so we get to the higher, then we are getting a positive response with 100 results had the positive response, and 600 had the negative response. And we can see how deep, how up it went. It went 0.5 upper to the third level, and it came 0.5 lower to the first level. So we see that the trend going down is a little bit higher here. And then in the third level, we got only, when the average was 3 here, and we got only one result, which was negative, and it came, we got 3 here, but it came down to the, from the third to the first level. So at this moment it looks like this. And you see, we have for each level we have the sum of deviations, and then we have how many these results were printed. So from that, if we divide 102 divided 189, we are getting 0.54 average deviation. If we divide 651 divided 1159, then deviation is 0.6. So this is how we calculate the deviation. So we have the sum of deviations, and then the number of deviations in the desired field, if it's positive or negative, and then we will get the average deviation. Final thing, the average deviation, we can also show there is a number of deviations. We can also see we have all the deviations in the 0, 1st, 2nd and 3rd level, and all these deviations, the number of them, we can recalculate these numbers. We can recalculate to the percentage, because the sum is 100, and we see that for example in the 2nd level the plus deviations are just 0.5 of all deviations. Most of deviations are raised from the 0, so we have 81% of results which came from 0, 0 and coming up. And very rare is just 0.1 is at this moment deviations in the 3rd level, because we got only one result coming to the negative until now. What I can do is on I can refresh, even it's off the proof, so it's not changing. I can refresh the values like here. Yeah, you see, and it's changing, the percentage is changing, the amount of deviations is increasing. You see, with every cycle it's increasing the number, and finally the sum of deviations is increasing, but the average is somehow stabilizing in some values. So that's what you can see, how far the gene is getting, how good is in its predictions following the wave-like theory, and that's the tool you can use. So that's I think all I wanted to say. Also I would add the average deviation, which we see here. It's then when we got new result, is printed in the result box, and it's here like a proof. And each result has because we were in the level, for example, that is level 3, and the level 3, as this 6 divided by 2, level 3 came to the level 3 to -2. It was negative, so we have -2 here. And we were in level, I think that's 4, it's 1.5, and it go to -0.5. It's 1.5 is actually the second level. So that's how the proof function is represented. It's just for better orientation, and it's good to know what is it for and what does it mean. Then the thing I said I will explain later is also the recuperation. We have now 5, and let me show it how it works. At first I will show it in the user guide. So we have still the third best result. It's still running. The speed is a little bit higher, but it can be even higher. And I go to the parameters. This we have here, and we go to the recuperation. So one thing, if the recuperation is 0, then it's disabled, and if it's more than 0, then it's enabled. The maximum recuperation makes sense. Minimum can be 1, and the maximum is count of previous slots plus count of future slots. In our case is 3 plus 2 is 5. Then what does it mean? If the recuperation I put 1, I will generate numbers like here, and we have here for P2. So I will take the same numbers, and when I am at the end of the generation in the input box, I will say the last column and place it into the first column and checking them with the history of the lottery. Yeah, so in this case is number 1. In the second case, if I decide to select number 3, then I am taking the last 3 generated numbers, and these last 3 I move them to the first. After the end, I move them to the first and checking them with the first, history, second and third. It's about that I will not, because I will compare only the first, second, third, and if I will not do the recuperation, these numbers which were not checked together with the history will be dismissed, will be removed and not checked, this combination possible, and this can cause that I can lose some nice matches. So using the recuperation, I can use all the possible matches, and all the numbers will be analyzed with the history. So if number 3, then the last 3 generated draws will be moved, and we place them, compare them, we calculate the number of matches, and then we generate new numbers from the generator. If we put the R max, which is in our case 5, and that's why it makes sense, because we moved this to the beginning, and we are checking now the second history and the second day, the numbers from the second day in the first day, the numbers from the third day we are checking in the second day, and so on, that we continue. And for the last needed generation, we generate new numbers from generation. Now just understand that if we put the recuperation 6, it doesn't make sense, as if we put 6, then we compare again the same numbers with the same result, which we already did. So the reasonable maximum is is in this case 5. If we put 6, it will anyway be reduced to the possible max. There is also recuperation if it will not pass the filter, then it takes until it did not pass and put them here. So we really do not lose anything, yeah. And in case the recuperation is 2, we ended here at the filter settings, then we put these numbers and we like it here, if we have the recuperation 2 max or 2. So these are the cases. I think at this moment it's evident how it works, and I will try to show it directly in the Gene, the monitoring box. So what I need to be somehow to pause it. Yeah, you see that trend. Just focus on number 66, then it's moved. Oh, sorry, let's just, I need to be able to pause it. And yeah, I do one thing. Let me go to I don't think I'm able to do it right now here, but doesn't matter. It means, maybe you will notice that, but when I am at the end, then I take, if I am at the end of the generation, then I take these numbers, the generator moves these numbers, the 32 is moved here, it's compared here, and when it's this one is moved to here, then new numbers are generated only here. So I'm generating only numbers at the end, and it's all moving like a strip of the movie film. So I will try to run it again and to see how it works. So it should be that 60 is moved, and it's moving the same number. 8 is moving here. It's quite quick, so maybe I try to make it slower a little bit, increasing some stuff here like that. Now it will be quite slow, I hope. Or rather to make other stuff, to make it slower. Yeah, I would switch it everything off. Yeah, you see the 52 was jumping here. 41. If you focus on one number, you see how it's moving. It means that the numbers are moved and new are generated here, and it's always moved and generated here. So it's how the recuperation works, and we are able to check all possible combinations. So I think that's enough, I said, for the recuperation at this moment. And we are getting to the end of this video tutorial, because I had explained all the things I have here, and all these things that were written here. And finally we just need to explain the gate, which is shown here, and the transfer. So at this moment, before I end it, I will do following. I will switch off the monitoring right here, set it up, and that switched off. We have the autosave. It was saved at 10 o'clock 25 minutes. The duration now at this moment is more than 1 hour. And what I am doing here now is switched off. So I switch on. Yeah, that's I wanted what might sometimes happen, something as I was playing a lot with that, but in good luck it was saved just a few minutes before. So if something happened, that's why it's good to have the auto saved on, if something happen, I can just close it. I will not save it, and I will open it again. Yeah, and we have it, and at this moment I'm ready to show the transfer function, as it was saved automatically, or if I save it, I can use the transfer, then click the activation setting and continue from the last save point, which was at 10 o'clock 25 minutes. And now it's running again. What I just wanted to show is the speed, so I switched off a few parameters like here, and it's switched off, it's running. And if you click to the notes tab, you will see now we will see the speed is 4000 cycles per second, but we might little bit wait, and now it increased to 14,000 cycles per second, and this is the speed we achieved today. Maybe it can be higher, it depends on your computer, on the other stuff is running on your computer and so on. But I don't know why it's really good to then to switch to Notes tab and to leave it running, because then there are objects not refreshed and it's really quick then. So you can see also that the speed is much more higher at this moment, and if you leave it like it is, then the speed average will be also very high. When I switched back, it just the speed reduced a little down. So that's I wanted to mention something about the speed. Then we have the speed. The gate I will keep later. Now a little bit to discuss about the transfer. So the transfer we use if we want to close the gene and we want to continue the generation after 1 day or on another computer, whatever. So what we do, we can, if we want to, we can end up the generation. We click the transfer and we can save the generation. Yeah. So I will, it's normally it's unchecked, so I will check it and save the generation like here. Then I can close it like I did before, because I had to, as it showed some overflow. And I just click the activation setting and start again. I don't need to do nothing more. You could also see that the last numbers were moved up, so everything, all the settings is correct, and it's continuing from the last save point, which was at 10 o'clock 32 minutes. I can pause it again. I can continue. And if we are just in front of the lottery day and you need to select the numbers, then do following. And the generation, you can just click the compare just to see the waves of the results, like this one, just directly in the input box. So this is the wave of the best result, and the best result number 3 we have here, so it's the same. Then we have wave of the result number 1 and result number 2, so we have actually 3 waves. So if we have more similar results, we can maybe decide not to choose the best one, but the one with the nicer trend, which is, for example, increasing or has some pattern. But in this case, it's we can just select the best result, and we select on our ticket these numbers. For the draw 1, you have this 18, 58, 20, 14, 54, and for draw 2 is number 6. we put on the kit, we buy it, pay the money, and we wait for the lottery, expecting about 2 or 3 numbers with this result. But our aim is to wait for much higher results than we got until now. So we selected the numbers on your ticket. We can double click the compare just to delete it and not to see it again here, and we can save it. Then when the lottery is played, but that I will show later after the lottery is over. In the meantime, I will explain the gate, and the gate, if we continue the generation, and now it continues at this moment, and it's preferred to have the gate 100. It's in percent, it's 100%. It can be from 1 to 100, and at this moment it says the gate is equal, it's 100 of the best result, so it's equal to the best result value, which is now 39. If we put 1%, it will be just 0.39. 50% will be something like 15, 17 or something like that. And in this case, it says the better, we will keep always the best result we have, but we can print similar results, which are because at this moment we can print only result with more than 39%, for example result with 40%, but maybe there can be situation that there are very similar results and we want to keep them, so then we like to reduce the gate, and to print the similar result we can put the gate to 99%, and you see the gate was reduced to 38%. So if there will be a result which has 39% like our best one, it will be printed like a fourth result, but the best result, which was printed first, will be still kept as a best result. So you don't to be afraid that you will lose the best result. This will not happen. If I reduce it, I can reduce it. You see how the gate is reduced, and we can reach results lower. Now we have 90%, at this moment is 35. If there will be for example 100, then it will be 90%, and this will change according to the best result. I can reduce it to 50, for example. Yeah, it's 50. I can just 50, yeah? It's 19%, and now you see we are getting more results which are higher than 19%, but you see they are already printed and we got already 55 results, 61 results, and they are still overwritten, but they have 22%. Many of them has 27% of matches, but they are still not higher than the best result we have here. So the best result is still kept in the position. So it's basically I would recommend to have the gate higher than it is. It's to not still overwrite it, and the new printed result then it's represented, which is not higher than the best result, is represented by the yellow wave here. So every new will change the yellow line, and you see we have the gate at 30%, and we are getting results, new results with 33%. It's result number 266, 67, and it's still going in the loop within the change. So my recommendation is to use 100 or 99 just to have the best result or very similar one. And then, as I mentioned, as I did the the compare, you can then compare the waves between each other and decide which result you will select for your ticket. So it's all about the gate. I wanted to mention, I put it back to 100, and the last thing we can do, we will end the generation. We made the compare. We selected the best wave, the numbers, as I mentioned before. Then we double click the compare just to remove it, not to see it here, because we will use it later, the compare again. We save the generation. We can also do a thing like this. I will copy the best result here, and I will paste it into the notes. That's why the notes we have here, just to keep our best result, and we can mark the numbers we decided to use for our lottery. I will mark them by red here. This we can keep. I can go back and then I will save it completely. Yeah, it's saved. Now I selected the numbers, I bought the ticket, and I wait for the result. In the meantime, it's closed, and I don't know, whatever you do, if you go to pub or whatever. And when it's time, I already have the new numbers of the lottery. I go back to the gene, opening that. And what I will do is just I put the new draw numbers into the compare column. So I can put it here. Just let me see. And for example, I had drawn number 9, then 58, then it was number 14, 6, and I don't know, for example, 54. Then it was number 3. These are the numbers we actually got. Then I click the compare to see what the result is immediately. It's usual when we are comparing more results, and we look for the best, and we see we got 3 matches with the real lottery, so we should win some small prize. We also see if we have other results, how many matches we have with other draws, and we can see we have only 1 match, which was with weaker, and we have less matches with the other draws, so we see that the best result is getting matches we desire here. So we can, again, I will take it like this. I will copy that here just to see the wave. We took these numbers, so I mark them red again, and at this moment we do not need to run the gene again. We can wait for the, as we see the wave looks nice, so there is a it's probable that we can have some good hits on the second upcoming day, so then we can take or buy a new ticket following these numbers. Depends what the wave looks like, how it's good, and that's why we decided to use the 2 future lots, because when we get the good wave, it's probable that the wave has the trend longer than it's we can use it. Also, we can keep it, and we can do following. We are keeping it for the reason that we keep the numbers we want to put in the future, but also we want to, if I double click the compare again, it's removed and so on, but I do not need to do it. But if I want to make a new generation after the lottery was played, I just uncheck the transfer and click the activation again. and all the interface is now empty, I can create new settings which I can keep most of the values, and I will add just the new numbers I got in the compare output input box from the lottery, and I start newly. In the meantime, I can also still keep the result I have here, so I can then decide if I use the new numbers I generated or I choose the numbers from the P1. So I hope that's all I wanted to show today, and I can finish it with end and save it in normal way. As it's not activated, then you can use this save. I can close it right now, and I can open it next day and continue new generation. So now I check the activation and continue like I did from the beginning, but much more quicker than today, because you know I provided really a deep walkthrough through the complete gene, and I'm at the end, and I believe the interface seemed to be more friendly and obvious to you than it was before. In fact, you got more familiar with Gene now. So thank you for your attention. If you miss something, just replay it. Please subscribe to the YouTube channel, click the bell to be notified about new upcoming video tutorials, provide your feedback, comments, and I'll be happy for every like I will get from you. Join us on the Facebook page, groups, follow the links in the description. Stay tuned and see you next time on the third video tutorial related to the security and protection. So have a nice day and bye bye.